And I want you to do part E first since we just did that. Okay, so you know f of 1 is 6. You want capital F of negative 3 and capital F of 5. Okay, so think about, where do we know? What do we already have? F of 1, this is our half. I'm going to do the want at F of 5 first because it'll be easier. So capital F of 5 equals capital F of 1 plus the integral from 1 to 5. What's capital F of 1? It was given to us. 6 plus. And then how am I going to evaluate this integral? Using the graph's area. Very good. So from 1 to 5, look at your picture. Shade from 1 to 5. Okay, my graph would be shaded from here to here. Oh, you can't see that. Okay, how big is that top triangle? 1/2 base times height. 1/2. My base here is how wide? 1, 2, 3 times 2. Because remember, your base doesn't even start until 1, so that first one doesn't count. Okay, so that'd be 3. And then what about this little halvesy one? 1 times 1 is 1, cut it in half is 1/2. So when I add my integral, it would be 3 and then minus 1/2 because that half is below. Yeah? Okay, and I'm just going to put 6 plus 3 minus 1/2 and call it a day. Okay, remember that's good enough. You could make it 9 minus 1/2 if you want to. Okay, put those whole numbers together, but I wouldn't get super into decimals and fractions and all that if you don't have to. Okay? All right, now you do it for f of negative 3. And your half part is going to be exactly the same. You're still starting at the same point. So then on that one, make sure the x minus 5 goes off there. So you want to write it on the bottom as well so they match. Okay, so you should have set up f of negative 3 equals f of 1 plus integral negative 3 to 1 of f of x d. Oops, what's wrong with what I just did? My order is backwards, and why was I switching it? Because I know later on if it's backwards, I'm going to reverse it. So go ahead and keep your 1 on the bottom, your negative 3 on top. Your half should always be on bottom. Your want should always be on top. Okay? Then from negative 3 to 1, let's come up to our picture. What shape is that? It's a semicircle. So I do pi r squared. And then cut it in half. My radius is only halfway across my circle, so my radius is a 2. So that'd be 4 pi, cut in half is 2 pi. Now, normally, since that area is below the x-axis, how would I count it? But if it's also backwards, what am I going to count it as? Positive. So it would be 6 plus 2 pi. Make sense? Okay, so go ahead and pull out your homework for me real quick. And I want to show you which question on your homework is asking that. It's the second FRQ, and it's like the last part of it. Okay?
So what would be 2 pi?
Because it's half of 4 pi. Because it was a circle. But it was only half of the circle. Yeah? Okay? So if you look at this one, right here. This one is where you're going to do that, okay? I don't want you to do it right now. I just want you to make a note or something that you probably couldn't have done that before today, okay? So for part D right here, you should now be able to do that, okay? All right, so let's go back to your notes. Okay, remember that what we learned yesterday was the chain rule version of the second fundamental theorem. So g of x, I'm going to put it over here, is the integral from 1 to x over 2 of f of t dt plus 3. Okay, so a couple things are different about this. The first thing that you should notice is different is that rather than this just being an x, it's x divided by 2. And then also we have a plus 3 over here. So the first thing we're going to do is find the derivative and then the second derivative. Okay, so g prime of x. What do I do with my x over 2? Plug it in because I'm taking the derivative of an integral. So this is my chain rule. F of, I'm going to write it as half x. Okay, but that's the same thing. And then chain rule, what we learned yesterday is you have to multiply by the derivative of that upper bound. So if it was a half x, what's the derivative of that? Times a half. Now question, what is going to happen with the plus 3 if I'm taking a derivative? Yeah, the derivative of this constant is going to go away. It's just going to be 0. Okay, now find g double prime for me. Okay, what's the derivative of f called? F prime of a half x. And then what do I need to multiply by from the middle? The derivative of a half x is another half. But if I already have a half, then I'd have a fourth. Okay, does that make sense? Do we need to go over that step more? Are we good? Good? Okay, so I'll do part A with you, then you'll do part B. Okay, part A says to find g of 2, g prime of 2, g double prime of 2. Let's do g of 2 first. And I'm plugging in to my x right here. So if I plug in a 2, that's the integral from 1 to 2 divided by 2. What is that? 1 of f of t dt plus 3. Well, what's the first part of that integral?
0.
If you're integrating from 1 to 1, that's just 0. 0 plus 3 is 3. Everybody good to there so far? Okay, part B. Or second part, g prime of 2. Okay, I'm using now this formula right here. What is the f going to be in the graph? Is it an area, a y value, or a slope? This is going to be a y value. Now, am I going to find the y value at 2?
No.
I'm going to find it at half of 2. What's half of 2?
1.
F of 1. And then what am I going to times that answer by because of chain rule? A half. So look at your graph. What is f of 1?
0.
F of 1 is 0. Half of 0 is still 0. Okay, g double prime at 2. Okay, I'm coming down to this formula right here. Okay, I'd want f prime at, and then when I plug in my 2 with my 1/2, what's half of 2 again? 1. And then I'm going to multiply that answer by a fourth. Now look at 1. F prime would be the slope. Can I find the slope at 1?
No, it's D&E.
Okay, why is it D&E?
Cusp.
Okay, that is a cusp. And so if part of it is, I know we haven't done limits in a while, but if part of it's D&E, the whole thing's D&E. So this would be D&E because f has a cusp at x equals 1. Okay, so now you do part B. Okay, now fourth period, when I asked them to do that, they were like, but Miss Joyner, the graph doesn't go to 8. True, but are you going to actually be looking at 8? No, what are you going to be looking at? 8 divided by 2 is 4. Does your graph go to 4? Yes. So that should not be a problem. So do your part B. Or the 10x minus 5x, yeah. Alright, so g of 8, hopefully you at least got some of it. Okay, g of 8 would have been the integral from 1 to where? 4 of f of t dt, and then what do you have to do at the end? Plus 3. Okay, 1 to 4, we already found that integral earlier. What did it come out to be?
6.
It was 3 minus a half, right? So it'd be 3 minus a half plus 3 at the end.
Why even a half?
Oh, was it only to 4? Sorry, no half. So then 3 plus 3 is 6. Okay, g prime of 8 would have been f of 4 times a half. What is f of 4? 0. Half of 0 is still 0. Okay, g double prime of 8 would have been f prime of 4 times a half, or a fourth. Okay, and then f prime at 4, what is the slope of this line segment?
-1.
-1 times a fourth is
Or -4.
-a fourth. We all get those? Great. Okay, next part, we want the equation of a tangent line. What two things do you need for the equation of a tangent line? Okay, point and slope. We want to be tangent to g, so that means that g of -6 is our point. G prime of -6 is going to be our slope. And now that we know how to find g and g prime, you should be able to do that. G of -6, where will my integral be from? 1 to -6?
No, 1 to
3. Why -3? Because that x that I plug in up there always has to get cut in half. So I'd have -3 f of t dt, and then plus 3. Now, we already found that shape earlier. From 1 to -3, it was 2 pi. Positive or negative if I'm going from 1 to -3? Positive. So it'd be 2 pi plus 3. That's my y value. So for my point, I'm going to put -6 comma 2 pi plus 3. Okay? Next thing I want is my slope. Remember, my slope is g prime. So we're plugging into this one right here. So it'll be f of, what's half of -6?
3.
F of -3, and then times a half. Okay, look at your graph at -3. What's your y value?
0.
Half of 0 is 0, so your slope is 0. And then remember, with the point and the slope, that's all that you need. You can write the equation of your line. So it'd be y minus 2 pi plus 3, and then 0, x plus 6. Now, obviously, if you're multiplying 0 by that x plus 6, you could just put a 0 over there and be fine. Okay? Alright, this is where it gets a little bit tricky. I want you to try to think about what we talked about yesterday. You have to pick x values so that when you cut them in half, you're at the right spot on the graph. Do you remember doing this yesterday? Okay, so on the graph, I want you to mark your mins and maxes. Remember that this is where y changes sign. So how many places does your graph pass through the x-axis? 3 times. 1 here, 1 here, and 1 here. Okay? -3 is a min or a max. Which one? Max. Okay, 1 is a min or a max? Min. And 4 is a max. Okay, now, obviously, we know that on the graph of f, -3, 1, and 4 are our numbers. But we have to pick x's that when I divide them by 2 are going to give me those numbers. So, for example, if I want 4, I would have to pick half of 8. So, come down here. I'm going to put relative max first at x equals 8. Okay, now I want you to think for a second about the other max. Don't say it out loud. Okay, the other max on the graph happens at -3. You have to pick a number so that before you cut it in half, okay, your number, when you cut it in half, has to give you -3. What would you pick? -6. Okay, because g prime, which is f of a half x, changes sign. From plus to minus. Okay, now do your relative min after you cut it in half, it should be a 1. Don't say it out loud. Okay, think about what x value do you have to list for your relative min so that when you cut it in half, you get 1. What should I pick? 2. Okay, because g prime, which is f of a half x times a half, changes from minus to plus. Okay, now we're going to do the same thing for points of inflection. So I'm going to give you a second to think about that before we do it. Points of inflection are f double prime, or I'm sorry, g double prime. What is g double prime in my graph? Okay, but it's the slope. So put x's on your graph everywhere that your slope changes sign. Where your slope changes sign. Okay, where should I put one of my x's? Okay, -1. How does the slope change there? From negative slope to positive slope. Okay, when does it change sign again? At 2. And do you see at 2, I'm uphill slope, then at 2, I switch to downhill. So your points of inflection occur at -1 and positive 2. Write on your paper what the x's should be so that when you cut them in half, you get those numbers. Half of what will give us -1? -2. Okay, so POI at -2. And then half of what will give us 2? 4. Because g double prime of x, which is f prime of a half x, times a fourth, changes. We'll just put changes sign. Because remember, for POIs, it doesn't matter which direction it changes sign, it just has to change sign. Okay, we have one more FRQ left. Okay, ready? Last one. Okay, part A says the functions f and g are given by, okay, we have f right here, we have g right here. Part A, you're asked to find f prime and g prime. Which of those, f or g, is going to involve fundamental theorem? F, because what does f have in it? An integral, and you're taking the derivative of an integral. That's when you're doing your fundamental theorem. Okay, so do part A. I want you to find f prime of x. And then I want you to find g prime of x. Okay, question on f. Are you doing normal second fundamental theorem or chain rule second fundamental theorem? Chain rule. And Nora, this is what you missed yesterday. So if it's a 3x, you plug in the whole 3x, but then you times by the derivative. What's the derivative of 3x? 3 in the front. So f prime of x is going to be a 3 in the front, and then when I switch in my 3x, now it's the square root of 4 plus 3x squared.
Wait, why would it be a 3?
What's the derivative of 3x? 3.
Wait, I thought you have to like multiply down the exponent. Yeah. So like 9x would be the prime.
Okay, no, you're not taking the derivative of this. You're taking the derivative of the end point. So can I go back one example? Okay, remember yesterday when we did this problem? Okay, what was our upper thing? 2x. What did we times by? 2. Okay, let's go back to the one that we just did. Yeah. We had a 1/2 x, we plugged it in, and then we times by a half. Let's go back to the very first page. Look at a couple of these. Okay, if I was doing the integral from this one right here, what was my number? 9x squared. Then what's the derivative of 9x squared? So you're not taking the derivative of this. You're taking the derivative of the end point. So look at your integral. U is the end point. Plug the end point in, then multiply by its derivative in front or in back, either one. Okay? Okay, so let's go back and look at our question. So we plugged in our 3x and then we times by 3. Everybody good with that? All right, G prime. What is the derivative of f on the outside? F prime of sine x. And then chain rule, I have to times by the derivative of the middle. Derivative of sine is cosine x. Very good. Okay, part A, done. Part B. Says, write an equation for the line tangent to the graph of G at pi. What two things do we need for the equation of a tangent line? Okay, point and slope. Okay, for my point, what's my x value? Pi. And my y value, if I want to be tangent to G, is going to be plug in pi here. So G of pi would be, I'm plugging in right here, f of sine pi. Is everybody good with that? Okay, and so sine pi, I'm just plugging in right there. What is the sine of pi though? 0. So what do I really want? F of 0. Now look back up at your thing. Where am I going to plug in 0 if I want f of 0? Am I plugging it in here or here? Where do you plug in if that's f of x? Here, right? Just like we've been doing on all the other ones. So where's my integral from now? 0 to 0, and we know what that is. What is it? 0 to 0 is 0. So we have our point. Pi comma 0. Yes, sir? That's going to be for the derivative. We're going to do that right now when we do slope. Good point. Okay, so next I want my slope. That's going to be G prime of pi. Okay, and so just like Justin said, we're plugging into this one now. Don't forget that cosine's back there. So f prime of sine of pi times cosine of pi. But remember, sine of pi is still 0. So I want f prime of 0. And then times, what is cosine of pi? Do we know that one? Instead of 1, what should it be if I'm at pi? -1. Now, how am I going to evaluate this? Am I going back to the one with the integral in it? Where's f prime? Remember we found it? So what am I plugging in? 0. Okay, well what's 0 times 3? Still 0. Square it. Add 4. So it's 3 times the square root of 4. What's the square root of 4? 2 times 3 is, so it's 6 times -1 is -6. So now I have my point, I have my slope, I can write the equation of my tangent line. So y minus 0, -6, x minus pi. And that would be your answer for part B. Okay? Alright, part C. Says, write but do not evaluate an integral expression that represents the max value of G on the interval. Okay, if I want a max, what do I want to change sign? Okay, I want G, if I want a max, I want G prime to do what? To change from positive to negative. Okay, so remember, in order for me to know where there's a sign change, I have to set G prime equal to 0. So let's set up our G prime of x, and then we're going to set it equal to 0 to look for our critical numbers. So for part C, I'm going to let G prime of x equal 0. Then I want it to change from plus to minus. That's the goal. I want G prime to change from plus to minus so that I know that I have a max. Okay? So let's figure out what G prime is. Look at your equation that we wrote earlier. It's f prime of sine x times cosine x. I'm going to write that down first. F prime of sine x times cosine x. Now, if I want to set this equal to 0, I need to replace this with something more algebraic. So what is f prime the same as? We did it up here. It's this, right? So if I want f prime of sine, where am I going to plug in sine? 4x, right?
Why did you set them up to 0?
Because I want to find my critical numbers. Because I want to find a max. Okay? So I'm going to take my sine x and I'm going to plug it in right here in my x of my f prime. So f prime of sine x is now going to be a sine plugged in right here. So it'll be 3 square root 4 plus 3 sine x squared cosine x 0. Now you're probably thinking, oh no, that looks worse. Okay, actually, look at this first chunk of math stuff right here. Okay, no matter what happens to this, when I square it, how's it going to turn out? Then you're going to add more positive stuff to it. Then you're going to square root it. What is this always going to be? Positive. So if I want a sign change, it's not going to change sign there. It's going to change sign here. When does cosine x equal 0? Which finger? When does cosine change sign? It's equal to 0 at pi over 2. Okay, you'd let cosine x equal 0. The only place that happens is at pi halves. Now let's think about a sign change. Okay, here's my number line. Here's pi halves. That's my critical number. If I plug in 0, what's the cosine of 0? 1. Positive 1, right? Then let's say I plug in pi. What's the cosine of pi? Negative 1. Did we find a max? Okay, because it would have gone from increasing to decreasing. And was it my only max? Yes? So then I know that's the absolute max. So my max occurs at, absolute max occurs at x equals pi halves. Okay, now let's go back up to our question, make sure we answered it all the way. Okay, what does it ask us to write? Okay, write but do not evaluate an integral expression that represents the max. Okay, well where does my max happen at? Pi halves. So I need to take pi halves and plug into where? If I want it to be the max of g, I need to plug into g. So my absolute max is g of pi halves. It occurs at pi halves. So if they want me to write an integral expression, I just need to plug in pi halves to g. So let's do that. Okay, look back up at your original. G is f of sine x. See it right here? So I want g of pi halves would be f of sine pi halves. What is f of sine pi halves the same as? What is sine pi halves? 1. And what is f of 1? Because I need to have an integral, and remember, f has an integral in it. F is the integral from 0 to 3x. What's our x, though? 1. 3 times 1 is 3. And then did it tell us we had to evaluate it? No. So that would be the end. Okay? Now, that one was kind of hard. Okay, there's not going to be one that hard on your quiz tomorrow. There could be one that hard on the AP test, but what makes it hard is knowing you have these two functions, you're plugging a bunch of crap in. Okay? Okay. There's one other thing I want to go over with you off of your homework. So turn to the very back question on your homework, and we're just going to review some calculator stuff. Okay? Huh? I don't think so. Did I? Yes. Oh, on the notes, we do need to do that one. We're going to do this first, though. Okay, I do need you to have a calculator. So if you don't have a calculator, okay, then I will happily bring you one. Anybody need one? Anybody else? Need one? Sure. Okay, we're going to do number 10. So go ahead, when you get your calculator, type that into y equals. Okay, number 10. Go ahead and type that into y equals. Okay?
Wait, is it number 10?
Yeah. So you're typing this into y equals. Okay. Once you get it typed in, part A asks you for average velocity. Remember, you have two choices when there's an average. It's either average y value or average rate of change A rock. Which one is part A if you want average velocity and this is a velocity? Average y value. What's the formula? 1 over b minus a, integral a to b, which would be 0 to 4. Very good. Okay, so this is average y value. So you would do 1 over 4 minus 0, integral 0 to 4, t minus 2 sine t. Okay, you know how to do that in the calculator? Please? Yes? Okay, math 9 will pull up your integral, and then I'd like for you to go ahead and just knock it out. Do it now. Okay, so do it. Yeah?
Can I get that homework?
Yeah, sure.
Not like it's good tomorrow. Yeah. I know, I have it right here. I just couldn't find 10. Never mind.
Flip over to the back. Then 10 comes after.
Never mind.
I started writing on 10 or 9.
No. Okay, did y'all get it? It's like negative 0.3 or something. Okay. All right. Part B. This time you want average acceleration. Is that average y value if this is velocity? That's average slope, which is average rate of change. So remember the difference. If it's a derivative, that's a slope. So you'd be doing v of 4 minus v of 0 over 4 minus 0. Okay, and then we remember how to do that in the calculator? Okay, so in your normal calculator mode, you have to have it typed in for it to do anything. Okay, but then you can hit alpha trace, and then pick y1 of 4 minus alpha trace, y1 at 0. And then what do I have to remember to divide by after I find the top? Divide by 4. Okay? So you would get negative 1.5136 over 4, which is negative 0.3784. Okay?
See that?
Sure. Okay? Alright, part C is going to be a version B. Okay, but you know how to do it. Okay, so at time 5, the particle's position is 2 feet to the left. What is x of 5?
2.
Positive or negative 2? Negative 2. That's what you have. What do you want the position at? At 12. This is what you want. So go ahead and set it up. And then remember the integral part you're going to do in your calculator. Okay? So it'd be x of 12 equals, and then you should be able to finish this other side.
So would it be integral and then 5, 12?
Yep, what should you have in front of that though? X of
5.
5 plus the integral from 5 to 12 of v of t dt. Okay, look up if you need it. It would be x of 5 plus the integral from 5 to 12. Then we already know what x of 5 is. What's x of 5? Negative 2. And then plus the integral, you can do that part in your calculator. So it'd be negative 2 plus, and then math 9, and then the integral from 5 to 12. Then in here, if I'm too lazy to type the whole thing in again, I can do alpha trace and just insert my y1. dx. So my position at that point would have been negative 9.1652. Okay, and then I never really did part A. Math 9, 0 to 4 of y1 dx. Okay, should your answer up here have been negative 1.44? You have to times by a fourth. So divide by 4. Oops. Divide by 4. So it should have been negative 0.3623. Okay, then the last question says, when does it change direction? I want you to edit that over 0 to 4. Otherwise, it changes direction like a gazillion times, and we don't want all those times. Okay? So how would I find when it changes direction if I don't want to set it equal to 0 by hand? Look for where it changes sign, and you can do that most easily in the graph. So graph your equation 0 to 4, and then I want you to find there are two places that your v of t changes sign. So when I graphed it, it looks like this. And so the two places that it changes sign would be here and here. One of them is a whole number, one of them is a decimal. So find those two. Are you in radian mode? You are? Okay. It should come out like that. And then this one is, anybody find the first one? 2? And then what's this one? 3.1415, which is pi. Now, could you have solved where it's equal to 0 by hand? Look at your equation. What will make t minus 2 0? 2. And what will make sine 0? Pi. So that should kind of make sense. Okay? And then if it said to justify, you'd say because v of t changes sign. Okay, on number 9, I'm going to have you change the equation. Otherwise, your car is going like 100,000 feet per minute, and that doesn't make sense. So just cross this out and make it ln of 3x plus 2. Now keep the integral part because you need that, okay? And now I will help you with parts A, B, and C at least for the setup, but the actual calculations you're going to do in your calculator. Okay, if I want the velocity at 3, this is velocity. How do I find the velocity at 3? Where do I plug in? To the equation to the endpoint. So where is my actual integral going to be from? 0 to 6 of ln 3x plus 2. How are you going to work that out in your calculator? Okay. Part B, we want the acceleration. What is acceleration if this is velocity? I need to take the derivative of the integral from 0 to 2x ln 3x plus 2. Okay, so think about what is that? That's what we just learned today, right? If you want the derivative of an integral, what do you switch out? Okay, your 2x is going to go where? Right here. And what will I need to times in the front? The derivative of the endpoint. Very good. What's the derivative of the endpoint here? 2. So it'll be 2 times the ln of 2x times 3 is now a 6x plus 2. And then where do I want the acceleration at, it says? 6. So I would take 6, bloop, plug it in there. Okay, then the last part, you want average acceleration. Average acceleration is a formula. What is the formula? Okay, it could be a rock or it could be 1 over b minus a integral a to b. So average acceleration, you're going to do 1 over b minus a integral a to b of 2 ln 6x plus 2. Now, you actually, the way this is written, you could do a rock, but you'd have to be using the original. Since there's an integral in it, that would kind of take forever. Okay? So what would it be? 1 over 3 minus 0, integral 0 to 3, and then how would you integrate that? Using your calculator, not by hand. 2 ln 6x plus 2. So average acceleration, if you have acceleration, would be your average value formula. Okay? Or if you were thinking AROC, v of 3 minus v of 0 would have been fine too. Okay? There's one other thing I forgot that I was going to go back and show you. I'm going to just tell you the rule. 5 and 6, do you see how they're both x's? There's a rule that says that you can break that integral down and make it 0 to x cubed, that's a t, minus 0 to x squared. So if you ever have an integral where both of them are x's, you can break it up, go 0 to the top, minus 0 to the bottom. And that's allowed. Now, if you want the derivative of that, you're doing then 2 fundamental theorems. So what would my first one be? What would I times by in the front? Cosine 2x cubed, but then times by what for chain rule? Derivative would be 3x squared cosine 2x cubed minus, then what do I do for the second one? Take that, bloop, plug it in, cosine of 2x squared, and then what do I times by in the front? 2x. Okay, number 6, same thing. You would break it down, 0 to the top, minus 0 to the bottom. And then you do 2 separate little rules. Okay? Okay, great.
I still don't get why you said that equation equal to 0.
How do you find critical numbers? You take the derivative. You set it equal to 0, right? That's how you find a critical number.
Oh, the line?
The line test, yeah.
And then what if you like have an arrow next to the max and then you say e and then pi over 2?
Okay, you're talking about, where are you talking about? Show me. Here?
Where you said like absolute, where you have like a root.
Oh, here?
Yeah.
Okay, so the reason that it's different is a lot of times it'll say where is the absolute max. So you'd give the x value, right? Okay, this doesn't say where, it says what is the absolute max value. So that means the y value. So if it happens at pi halves, I have to go back and plug pi halves back into g to know what that is. But then the thing that's kind of tricky about it is that when you plug in pi halves, you have to plug into g first. Oops, my d's covered. You'd have to plug into g first, but then what does g have in it? An f. So you plug into g, find the sine of pi halves is 1, and then take 1 and plug in pi, have a good day, into f.
You plug it into the g because it said the maximum value
Of g, correct. So if it had said the max value of f, then you would have let f prime equal 0 and find where that happens. But since it said the max of g, you take g prime equal to 0, and then look for your sign change.
Are you free to start machine?
Yes.
Anthony, let's go.
We're maybe going to agree to the review. So just remind me.
Okay, so.
Great?
No.
Great?
Thank you, Valerie.
Okay, so can we finish that?
I got it.
So
I was supposed to be my divide ticket.
it is. Perfect. Thank you. So, and then for your divide bys, you need to do flip over. For your divide bys, these you have to do long division on because you can't shortcut them.
Okay, so
you put 2x plus 5 divided into, and then put the long. Yep, just like that.
Okay.
Okay.
Yeah. This is so stressful, miss.
It's a lot more stressful when you wait until the last week.
Miss, I wasn't here for 3 days.
Okay, 3 days. That was like a week ago, girl.
No, it wasn't. It was last week.
No, we did that long division stuff 2 weeks ago. So you've been having that for a while. It's okay though, but that's why it's kind of all
And I
caught up
still
on you.
need 21, 22, and 23.
Okay.
I don't know how I'm gonna get this stuff in, miss. This is hard.
Okay, well 21, 22, and 23 are all from last week.
Okay.
So that's over what your test is over. So
The one I
here's
just took
23.
or the one that
The
we're
one
taking
that's
tomorrow?
tomorrow. So it's like the factoring and stuff like that. Okay? Now remember, your lowest grade in the homework and the quiz categories are both dropped.
They're already dropped. This is like, those are zeros that are
Okay, but I'm just saying like 1 or 2 zeros is not going to kill your grade. The main things you have to fix are any quizzes that are zeros,
Okay.
and then any reviews will go in the quiz category, so you don't want zeros for those.
Alright. And I found my homework 14 and 17.
Okay, yeah, just give it to me. I'm typing in grades pretty much all day today.
But I didn't complete it. Like, I don't even remember what they're about.
So when you say you found them, you mean you found blank homeworks that are not done.
They're partially done.
Okay.